All right, this is 7th grade, Module 4, Lesson 6, Fluency with Percents. All right, now this is the last lesson of this topic, which means there will be the finishing of your notebook at this point and a quick quiz. So hopefully by now you're pretty confident with your percentages and how to find your percentages and how to set up your proportional relationships to solve for those percentages. So let's keep going here. We have an opening exercise. It says solve the following problem using mental math only, which you guys know I want you to show your work. So we're not going to do the mental math. So I'm actually going to kind of cross that out. Be prepared to discuss your method with your classmates. All right. So there will be some comparing here with your table partners here in a second. But first, let's get started. Corey and Everett have collected model cars since the 3rd grade. Corey has 80 model cars in his collection, which is 25% more than Everett has. Little words that you should have picked up by now in all these lessons is when you see something that says more than another person, that means you're going to have 100% plus an additional percentage. All right, so we have 100% would be the total number. Now, because if they were equal, if Corey and Everett had the same exact amount of cars. But because Corey has 25% more, we're going to add that to the 100%. And so Corey has 125% of the cars. So when we set up our proportional relationship, we know that the bottom here is always 100. And since we're dealing with 125% from Corey, and that's 80 additional cars, what is the 100%? What would be the equal number? Basically, how much does Everett have? This is Corey and this is Everett. So we're going to cross multiply now, and we're going to get 125 times x gives me 125x. 80 times 100, it's going to give me 8,000. And when we divide these out, the 125s cancel, and if you do this on your calculator correctly, you will find out that there is 64 cars that Everett has. So if both boys had, that's Everett's cars. If both boys had 64%, it would be 100%. But because Corey has 80 more cars, or 80 cars, then he has an increase of 25%. So Corey has 80 cars. Everett has 64 cars. Let's look at example 1. 75% of the students in Jesse's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches taller? So we're going to set this up as line equals line. All right. 100% is the entire class. Now, 75% of them are going to be 60 inches or taller. Okay. If there are 20 students, so there are 20 students in the class, how many of them are 60 inches taller? All right, so let's go ahead and cross multiply this out. I don't want to use yellow. Let's use blue. This is going to give me 100x, and 75 times 20 is going to give me 1,500. I'm going to divide out my 100, and that gives me that 15 students. So of a class of 20 students, 15 of them are 60 inches or taller. All right, I'm going to scroll this down. All right, B. Bobby wants to leave a tip for her waitress to equal 15% of her bill. Bobby's bill is $18. So what is 15% of the $18? So basically, how much of a tip should Bobby leave? All right. So the easiest way to do this, instead of setting it all up, to be honest, you could do that, but I'm going to show you a little faster way instead of doing the proportional relationship. When it's something as straightforward as this, and this is what you can do when you're actually at a restaurant. If the bill is $18, and I want to know what 15% of that is, I'm just going to multiply by decimal 15. If you remember this back from, I believe it's lesson 1 or lesson 2, 15%, when we transferred that into a decimal, was just point and the number. So you would take your calculator. Okay, if you're sitting at a restaurant, do 18 times decimal 15, and it's $2.70. So the tip would be $2.70. Now, of course, that's just what the tip is. If you wanted to know what the total amount you have to pay, then you would add that to your $18, and that would be a $20.70 bill total, and that's including the tip. But in this question here, it just wants to know how much is the 15%. It would be $2.70. All right, let's move on down here to the exercises. All right, express 9 hours as a percentage of 3 days. All right, so 3 days, first of all, we're talking about days and hours, so we need to change that. So 3 days, that's going to be 3 times 24, because there's 24 hours in a day. So this is a total of 72 hours. Now, I'm going to set this up as line equals line. I have 9 hours. How much of that, what is the percentage of that? So 72 hours for the 3 days. So 9 of the 72 hours is how many of the 100? So we're going to cross multiply here, and I'm going to get 72x, and 9 times 100 is 900. Divide that out on your calculators. And when you divide that out, you should get 12.5%. All right. Let's look at number 2. Richard works from 11 a.m. to 3 a.m., so over 24 hours. His dinner break is 75% of the way through his shift. What time is his dinner break? So how many hours has he worked? From 11 a.m. to 3 a.m., that is 16 hours. So he's worked 16 hours. Okay, I'm actually going to let you solve this one out, but I'm going to set it up here. He's worked 16 hours. 16 hours, he gets a break at 75% through his shift. So you need to find out what hour that would be, and then tell me what is the time represented at that hour. Okay, so go ahead and solve that one out. I'll meet you back at number 3. Okay, so we're on number 3 now. At a playoff basketball game, there were 370 fans cheering for a school A and 555 fans cheering for school B. Express the number of fans cheering for school A as a percent of numbers cheering for school B. So let's set this up as our proportional relationship here of is over of equals percent over 100. Now it's asking me what is the percent, so I know that's going to be my x. School A has 370 people cheering. School B has 555 people cheering. So we're going to cross multiply these like we've been doing this whole time. I'm going to get 555x, multiply these two together, equals 37,000. Divide out that 555, excuse me. Take your calculator, because that's quite big. We're going to say 37,000 divided by 555. Oh, wow, we have a repeat decimal, which we can't have. So it's 65.6 repeating. Now, in my class, you all know that 0.6 repeating is 2/3. So 66 2/3%. And there's your answer. Now let's look at part B. Express the number of fans cheering for school B as a percent of the number of people cheering for school A. So basically, we just flipped it. So we went from school A to school B. Now we're going to go from school B to school A. So let's set this up as our proportional relationship again. So line equals line, always over 100. And we're basically going to flip these two. So I'm going to put 555 here and 370 here, and I'm going to solve for that percentage again. All right, I'm going to let you solve this one out. Since we've already done it up above, we're just flipping it around. So go ahead and pause the video, and I'll meet you on C. Okay, so hopefully you found that answer. Now let's look at C. What percent more fans were there for school B than there were for school A? So you would take your school B percent of 150 and your school A percent of 100. And if you subtracted that, you would have 50% more. There was 50% more people for school B than for school A. All right, let's look at number 4. Rectangle A has a width of 8 centimeters and a length of 16 centimeters. Rectangle B has the same area as the first, but its width is 62.5% of the width of rectangle A. So it's bigger, okay? Express the length of rectangle B as a percent of rectangle A. All right, so rectangle A, let's kind of draw a picture here. It's not drawn to scale, obviously. This is A. It has a width of 8 and a length of 16. And then B over here has the same area. All right, well, area equals length times width, which would be 8 times 16, which will give us 128 centimeters. So they have the same area. So when I multiply these two, I'll get 128 as well. But its width is 62.5% of the width of the first rectangle. So I'm going to take the width here of 8 and I'm going to times it by 0.625. And all I did was I moved that decimal back 2 places. So when I multiply that through on my calculator, I'm going to get 128 centimeters. Oh, just kidding. I thought that sounded weird. I'm not going to get 128. I just found my area twice. I apologize. I'm going to multiply those together on my calculator. I'm going to get 5. So my width over here is 5 centimeters. So it actually got smaller. All right. So what is the area for B then? So what is its length is basically what I'm solving for. So I know if the area is 128 and it's 5 times the length, then I'm solving for the x. So let's go ahead and divide out that 5. The 5's cancel. And 128 divided by 5 equals 25.6 centimeters. So this here would be 25.6 there. Now, I'm going to set this up like a proportion. So we're going to say line equals line, always over 100. I'm looking for x because it says what is the percent more or less. All right. So we have the 25.6 that we just found, and we're going to set that equivalent to the 16 over here. We're going to cross multiply, and I'm going to get 16x equals, multiply these guys, we get 22,560. Divide out the 16s. Those cancel, and my remaining is going to be 160. So it's 160% more or less, depending on what direction you're going in. This is going less, and this is going more. All right, let's try the next one. I'll meet you on number 5. All right, number 5 says, a plant in Michaela's garden was 40 inches tall one day and was 4 feet tall a week later. What is the percent of her heights increase over the week? So one thing you got to notice here is we're dealing with 2 different types of measurement. We went from 40 inches to 4 feet. So we need to fix that. So 4 feet is equal to 48 inches. So the plant went from 40 inches to 48 inches. And the question's asking, what is that percent? So we're going to do line equals line, always over 100. We're looking for the percent, and I'm going to let you figure out what goes over here. So go ahead and solve out number 5, and I'll meet you on number 6. Okay, so this is the last problem of this lesson. We have number 6. Lauren must obtain a minimum number of signatures on a petition before it can be submitted. She was able to obtain 672 signatures, which is 40% more than what she needs. How many signatures does she need? Now, I'm going to draw your attention to this wording here, 40% more. So 100% is everything, and she wants 40% more. So she wants 140%. Okay? I'm going to have you finish this up. Find out how many signatures are needed for her to gain her 140%. And that is the end of this training module for lesson 6 and for the end of topic A. And I hope it helped.